Hey everyone, Dr. Keith here. Let's go ahead and practice what we did in class, or what you will be doing in class, depending on when you watch this, with Azure Machine Learning Studio. So, if you haven't already, before this video, what I'd like you to do is, well, obviously first log in and get to your main screen here. You may not have these experiments saved yet, but come down here to New and go through this experimental tutorial. You can do that without watching this video. Just walk through that. Remember as best you can the steps and the pieces, but we're going to replicate that now in this video. So, assuming you've now done that, let's move on. We're going to use the bike buyers data set that we've been using in class. So let's go to Learning Suite, log in. Alright, capstone, class, schedule, and I want you to get the bike buyers data from a few days ago. Or your version of this class may look a bit different. Just look for this bikebuyers.xlsm file. We're going to open this up and create a .csv version. So the free version of Machine Learning Studio that you guys have allows only certain data sets. So here's bike buyers. I've already uploaded it before, but I'm going to go ahead and click New and let you see what options you have. Now, unfortunately, because you're using this free student version, you only get to upload a local file. You can't connect to a SQL Server database. So for my class, feel free to export whatever data you have into a CSV, and we'll upload it here. So first thing we need to do, or next thing we need to do, sorry, is come here to this data file we just downloaded and turn it into a CSV. So not hard to do. We've got a few tabs. We're going to stick with this numeric tab because it has both the categorical versions and the numeric versions of the data. And depending on the algorithm we choose, we may or may not be able to use the categorical variables, but if we can, we actually would like to use those. But if we can't, at least we have the numeric versions. So let's go ahead and just save this numeric sheet by going to File, Save As, change it to a CSV. Let's pick a location. I'm in downloads. Looks like I've done this a bazillion times already. Let's change the file type once more. CSV, there we go. Alright, I'm going to call this bike buyers, just like that. So it says you've got multiple sheets. We can't support that. No problem. Just hit OK. Now it looks like we still have the sheets. If I were to close this out though, don't save, I've already saved a copy. And if I were to open Windows Explorer, or File Explorer, whatever they call it these days, and go to Downloads, working on it, take your time, sorted by date. Here we go. Open it up from this view. You'll now notice, yes, just hit yes, not a problem, don't worry about it. You'll now notice there's only one tab, and we don't have that table built in because this is Excel reading a comma-separated values file. So this just means everything's fine. I'm going to close that out, and now come here to upload a new data set. Choose a file, grab bike buyers. I've named it different, so it's not a new version of an existing data set. I'm just going to upload it as is. Alright, down here it says we are now working on uploading. Awesome. Don't worry, this will only take a second. We can actually go now to the experiments page, and it'll continue working on uploading that new data set. Alright, so I've got some leftover files here from the experiment tutorial. Hopefully you've done that now and you'll have these as well. Let's go ahead and create a new experiment. Yep, it says uploads complete. Okay. Let's come here to New, Blank Experiment. Alright, and it gives us a nice little diagram here of exactly what pieces we'll need to do a prediction. Alright, so let's change this to bike buyers demo. First thing we need is our data set. So, saved data sets. Try that again. There we go. My data sets. Notice they've got all kinds of sample data, census data, which is actually useful. I would use that in some real projects. Interesting stuff. Anyway, let's come here and select the data set we just uploaded and drop it right here. It doesn't have to be exactly there, just somewhere here. Okay, what's the next thing we need? We need to split the data. Now, actually, before I split, I'm going to show you one other thing. What we're going to do, we're not going to use every column in that data set. For this first demo, we're only going to use a few. So what we need is a transform. Actually, no, I can do better than that. I think what it's called is select columns. There we go. Select columns in data set. That's what we want. So we're going to put this here, and we're going to launch the column selector. And sometimes this, sometimes when I click on this, it'll bring up my list of columns, and other times it won't. So we want to include, let's start with our dependent variable, purchase bike numeric. There we go, it sees it. Still not working. Here's what we're going to have to do. Let's go back and reopen that CSV file so we can see the names of all the columns we want to include. Yes, open it, relax. I wonder if we can make life easy by just copying all of these. Let's see if this works. Paste. Nope. Nice try. Looks like we're doing it one at a time. Copy. Paste. Space. Copy. Paste. Space. Whoops. Back. That was an accident. Alright. Okay, back to this. Let's try that again. Copy. Okay, that should do it. Include just those. So I'm including only the numeric columns because this time through I'm going to run just a regression model. So space, let's see if that works out. Yep, there we go. Check. And now it's your problem. Oh, connect. There we go. I like that I can delete this connection to here. I want to show you. Once I click and drag, it turns green if I'm allowed to connect from here to that spot. So anyway, I've selected only the numeric columns so that I can use a linear regression, which requires numeric variables. If I change from using a linear regression, I can come back in here, launch the column selector, and just tell it to include everything or something like that. So anyway, now that I've selected the columns I want, let's do data split. So if you remember in class, let's type in split here. Split data, there it is. The purpose of a split, connect the dots here first. Whoops. There we go. Purpose of a split is to prevent what's called overfitting the data. So we don't know for sure if the data we have is a perfect random sample of the intended population that we want to predict for. So for example, the customers that we have come in to buy bikes, in fact we know it's not a perfectly random sample of everybody that we want to potentially sell a bike to. So what we need to do is to prevent developing or calculating regression coefficients that apply too specifically to our sample. What we're going to do is split the data up and use 70% of the data, and really anywhere between 50 and 80, 90% is really okay. This is arbitrary, choosing 70%. But we're going to say 70% of the data will be used to calculate the regression coefficients. And then when we calculate those coefficients, we'll save and hold out the other 30%. We're going to pretend like we don't know if those other 30% bought a bike or not, and then we're going to then predict whether or not they'll buy a bike only for that 30%. And we're going to calculate our accuracy and see how accurately we predicted whether or not those 30% bought a bike. So this isn't a perfect fix to prevent overfitting the data, but it will pull back some of the coefficients a bit and reduce our accuracy a little bit, just in case our predictions are too well fit or overfit for our specific sample. Anyway, come down here, random seed, just put in something like 1, 2, 3, 4, 5. It really doesn't matter what you use there too much. Stratified split, we're going to leave this as false. What this means is you may want to have a perfect representation of 50% male and 50% female. Or maybe I am doing a political poll and I want to get exactly 100 people from every state. Stratified means randomly select until I fill 100 of each type or of each state. Or, if I know I'm going to select 1,000 rows, or if 70% is represented by 700, let's say, and I want it even between male and female, stratified means it'll randomly select up to 50% of either, and as soon as it hits 50% of one, it will only select the other until it gets 50%. In this case, let's not worry about stratifying, but notice that if I were to hit true, then I can sit here and select the columns that I want to stratify based on and all that stuff. It's pretty straightforward. But I'll change that to false. Okay, next we've split the data. There's two more things we need. Not two more, there's several more, but there's two things we can add next. One, we need to pick our algorithm. So rather than search for it, I want to show you where to find all of your options. We're going to come down here to the machine learning option, expand that. I'm going to take off score and go to, we're going to need train model in just a moment. I'm going to pull that out here and get it ready. Actually, I'll put it right about here. But what I want you to go to next is the evaluate. Oh, sorry, no. Initialize, not evaluate. And here's our four types of algorithms that we'll use in this class. Classification, we use each of these or something from this family when the dependent variable is categorical and perhaps not ordered, or we don't want to treat it as something ordered. It's categorical and we want to predict yes or no. Now we could do this with our data if we used as our dependent variable the purchase byte column and not purchase byte numeric. Because the purchase byte column, if you remember from our data here, this is categorical. It's yes or no. And perhaps we don't want to assign an order to yes or no. We don't want to mark one as 0 and the other one as 1. We can use a classification algorithm to classify it as a yes or a no rather than as a 0 or a 1. And sometimes our accuracy is much better that way. So typically we end up trying a lot of different models to see what is best. However, I, in my select columns here, pulled in the purchase byte numeric, which means we need to use one of these regression models. And any of these will work. Let's start with our classic linear regression because you're going to recognize some of the values here in the coefficients from our time that we did this in Excel. Alright, let me make a bit of room. Okay, so you'll notice split data has two output connectors. Train model has two inputs and linear regression has one output. Let's grab linear regression and notice it highlights in green the one we're allowed to connect it to. Split data, we can grab either one of these, but to keep it nicely organized, let's use this one right here. Train model's got this little problem here, so we click on it, and it wants us to launch the column selector. Basically, it wants us to tell it which variable are we trying to predict. It gives us that clue by saying select a single column, which means this is going to be the dependent variable. Here you can see now it's giving me my list of possible variables. I wish it did that before. That would have made life a bit easier. But anyway, select purchase byte numeric. Even if I try to pick something else, then I get this little, hey, you can't select more than one. Delete that one. All right, no problem. Train model's good. Linear regression's good. Okay, what comes next? If you remember from the tutorial, then you'll know the next one is to score the model. So this is also here under machine learning. You could search for it if you want to, but we'll click and drag. Score model needs two inputs. So one of them is going to come from train model. Now let's liken this to what we did in Excel previously. Train model is the equivalent of us calculating the coefficients in Excel. So for example, when we did this before, train the model is equivalent of going to data analysis, and then picking regression, okay, and then saying, okay, the Y range is purchase byte numeric, great, X range is everything else that we want to include in that are predictors. That includes the labels. We're going to print this out. Where to? It's going to be over here somewhere, and okay. This process right here of coming up with these coefficients, coming up with the intercept, all of this, that's what's happening right here in the train model. Okay? So score model is then what? Well, okay, it happens after the model's trained, and I need this connector from split data. Why? Because score model is when we then go and calculate the formula to take the coefficients that were produced and then generate a predicted score for what? For everything? No, we connect it to split data so that it knows to score the model only for the remaining 30% that we hold out for testing. That's why split data's got to also connect to score model, so it knows which variable or which instances to use to score the model for. So if you've forgotten what I mean by this, here's what we do with score model. It's equivalent of in Excel. Let's insert a couple rows. Insert. Let's come back here. Let's grab our coefficients. Copy. We're going to paste special. Or we're going to transform. No, sorry, not right there. I want to put it right here. I'm going to hide some of these. Hide. Whoops, no, not clear. Hide. Okay, we're going to insert a predicted column here. And we're going to say this is going to equal some product of this array. And I'm going to F4 that so it stays on that row. Multiplied and added to this array, which I'm going to leave that way so that it can copy paste down. And then I'm going to add to that, hopefully you remember, the intercept, the coefficient for the intercept. So this gives me a value based on this purchase bike value between 0 and 1. This is my predicted value. Anything below 0.5 would round to 0, which is a prediction of no. Round to 1 means a prediction of yes. So I'm going to copy paste that down. What I'm doing right here, this is the equivalent of scoring the model. Taking those predicted coefficients and then calculating a score, but only, again, for that 30% that we held out for testing. So we can actually, well, no, hold off. We need to do one more thing. Lastly, we need to evaluate the model. So evaluate model. Run out of space here. Does that help? No, that doesn't help. Let's move these up a bit. Okay, click from here into one of the two evaluates. We don't need to use the other one, not a problem. Evaluate the model is what we do right here. It's saying, okay, how good was our prediction? And of course we have an R-squared here, but this evaluate model will give us a little bit more information. So what we need to do next, we've simply set up this project hypothetically. We haven't actually executed anything. I want to save it, and then let's run it. Okay, so we sit here and chill. It queues up a bunch of tasks, selects columns, grabs the formula, splits the data, decides which ones to use to calculate the coefficients, randomly selects that 70%, that's what's happening right there. Now it's going to start training the model, calculating the coefficients. Now it's going to use that formula to come up with a prediction for the holdout data, and then it's going to calculate R-squared and several other things. Okay, overall under a minute, not bad. So here's what we're going to do next. Let's start by viewing or visualizing the results of the trained model. So I come here. What it gives us are the regression coefficients. So this is interesting. Bias, by the way, this is just the intercept. So let's see how close these were to the ones we had. So we had for, let's see what this one is, marital status, negative 0.12. Marital status, we have negative 0.13 here in Excel. Cars, negative 0.09. Cars, negative 0.10. You'll notice they're all very close to what we came up with in Excel. But why aren't they the same? It's the same formula, right? Shouldn't it be the exact same coefficients? Notice even our intercept is very similar. Okay, hopefully you've thought through this. The reason why these are different is because of this split right here. We randomly selected 70% of the data to rerun the coefficients based on. And the predictions are going to be slightly less accurate overall because of that, because we're not using all of the data and we're trying not to overfit the data. But they're going to be very similar, and that's exactly what happened. So that was train model. Let's take a look at score model now. Score dataset, visualize. Okay, what we get here is a list of all of our columns, and I love that it gives us these little histograms here to show us the distribution of the data so we can see how normal or bell-shaped these curves are. So here's our scored labels. Does it tell me? No, I don't have ID, so I can't tell you for sure how close this prediction is to the one we have in Excel. But look, you can see it's very much like our predictions that we have right here. Oh, I forgot to copy this down. Oh, and also this needs to be F4'd so it stays on the same cell. Now let's copy that down. There we go. These predictions look a lot like these predictions here. Last thing, evaluate model. Right click, evaluation results, visualize. Okay, so we get here the coefficient of determination. That's another fancy word for R squared. Notice R squared here is 0.091. Maybe it'll round up to 0.92. Whereas here, it was already at 0.925. It rounds up to 0.93. So just like I said, because we used only part of the data set, our prediction is going to be not quite as good as it was before because we're trying not to overfit the data. And that's exactly what happened. R squared was slightly smaller. So these values here simply say mean absolute error. All of our predictions, will generally be a simple explanation for this, within 0.45 of the predicted value. So the actual score will always be, or will likely be, and then this is just a percentage of that, within 90% of the actual prediction. So not a great percentage actually. However, it's really not that bad when you consider what this is telling us right here. This doesn't mean that we're going to be right 9% of the time when we're predicting whether or not someone buys a bike. It means we're going to be right 9% more than if we were to randomly guess whether or not they'll buy a bike. So even though this may seem small and our prediction here may seem not very precise, the baseline is guessing. So it's this much better than a completely random guess. Anyway, I'm going to stop this video here. So here's how we do what we did in Excel before, come up with a prediction in Machine Learning Studio. The next video will be how to then set this up as a web service and consume the service.